What you are about to witness is one of the most remarkable transformations in modern manufacturing. Every year, billions of banana stems are discarded as agricultural waste, left to rot in fields around the world. But inside this futuristic AI-powered facility, that very waste is reborn as one of the most valuable sustainable materials of the 21st century. From raw stem to high-grade textile fiber, organic fertilizer, and bioliquid extracts, nothing is wasted here. Welcome to the future of green manufacturing. Let's step inside. The journey begins at the factory gate, where a sleek silver transport truck arrives carrying tons of freshly harvested banana stems. As the vehicle slows down, it enters a high-tech scanning tunnel illuminated by glowing blue neon lights. Advanced sensors and cameras instantly verify the shipment, scanning every inch of the cargo for quality, weight, and authenticity. There are no clipboards, no manual checks, just pure digital precision. Within seconds, the truck is cleared and guided into the unloading bay, where automation takes over completely. Inside the facility, a powerful overhead crane, equipped with a specialized robotic claw, descends with mechanical grace. It lifts massive bundles of banana stems and gently places them onto a moving conveyor system. A digital scale flashes 1,240 kilograms as the raw material is automatically weighed. At a nearby control terminal, a technician in safety gear logs the shipment into the factory's ERP system. The screen confirms, batch registration successful. Every stem is now tracked, traced, and accounted for in real time, ensuring complete transparency from farm to finished product. Now, the real intelligence begins. Each stem passes beneath a robotic arm fitted with a circular AI scanner. Computer vision systems analyze color, texture, and structural integrity at lightning speed. Suddenly, a red warning light flashes. Damage detected. Instantly, a mechanical arm flicks the defective piece off the line. Only the healthiest stems continue forward, where automated rotating blades slice them into perfectly uniform chunks. This is precision manufacturing at its finest, where artificial intelligence meets agricultural innovation. The chopped stems then enter the massive Rotaire washing zone. High-pressure water jets blast away dirt, sap, and residue as the pieces tumble inside enormous rotating drums. The water quickly darkens, but nothing here is wasted. The murky runoff flows directly into advanced filtration systems, where it is purified, recycled, and reused. The stems pass through additional purification tanks filled with crystal clear water, ensuring absolute cleanliness before the next phase. This closed-loop water system saves millions of liters every year, a cornerstone of true sustainable production. Clean and pristine, the stems are mechanically aligned in perfect rows before passing through a series of high-speed circular saw blades that cut them with surgical precision. Next, they glide beneath red laser scanners that map their internal structure in 3 dimensions. On the live monitor, the system classifies each stem by fiber grade and yield potential. Based on this AI analysis, mechanical flippers gently divert each piece into its appropriate channel. Premium grade fibers in one path, standard grade in another. Every decision is made in milliseconds with zero room for error. And now, the most magical moment in the entire factory. The grated stems enter the fiber extraction unit, where powerful machines crush, press, and strip the plant tissue. The fleshy pulp separates from the outer layers, and suddenly, long, silky white strands of pure banana fiber emerge, flowing like cascading hair. This is what nature has hidden inside every banana stem for millions of years. A fiber so strong, lightweight, and biodegradable that it rivals cotton, silk, and even synthetic textiles. What was once considered waste has just been transformed into pure botanical gold. The raw fiber is far from finished. It is washed again and passed through precision rollers that flatten and align it into continuous, even sheets. From there, robotic hooks gently lift bundles of fiber and submerge them into the bio-degumming section. Vats filled with eco-friendly bioliquids that soften the strands and remove natural resins and gums. This is what gives banana fiber its textile-grade quality, smooth, flexible, and ready to be woven into everything from fine fabrics to industrial rope. Every dip, every cycle, every second is monitored by sensors to perfection. The treated fibers now travel through a massive industrial drying oven. On the control screen, real-time data flows. Optimal viscosity, moisture level, 75%, 60%, 40%, 20%. Infrared sensors track every degree, every percentage point, ensuring the fiber dries evenly without losing strength or flexibility. After the first drying phase, the fibers, now a beautiful golden brown, are rinsed once more and chemically balanced. The pH reads 6.6, perfectly neutral. They are then hung on moving racks to pass through a secondary drying chamber, where finishing temperatures lock in their final texture. To make the fibers truly soft and luxurious, bundles are submerged in swirling vortex tanks, where rotating currents loosen each strand individually. Then comes large-scale rinsing, sprayed with clean water and hung in elegant rows to drip dry. Finally, loose fibers travel on wide belts through enormous industrial ovens calibrated to precisely 75 to 80 degrees Celsius. Bulk drying is the final environmental step before quality testing begins. Every fiber that emerges from this oven is uniform, durable, and ready for the toughest test yet. We now enter the laboratory, the brain of the operation. Scientists in white coats and protective goggles examine each batch under high-powered magnifying lenses. A robotic arm clamps onto a bundle of fiber and pulls with steadily increasing force, measuring tensile strength in newtons. The fiber stretches, resists, and finally snaps, and the screen lights up with one beautiful word: pass. Every batch must meet rigorous international standards before it can leave this room. Quality is not a feature here, it is a guarantee. Approved fibers move forward, while any inconsistencies are diverted to pulp recycling. Handheld sensors confirm a perfect moisture level of 10.2%. The fibers are then rolled into giant industrial cylinders or compressed into neat bales. Robotic arms apply QR-coded labels with full traceability, origin, batch number, grade, and certification, all scannable in seconds. From this point forward, every bundle can be tracked across the globe. Some are destined for textile factories in Europe, others for paper mills in Asia, and many for sustainable fashion brands worldwide. But the story doesn't end with fiber. The leftover pulp is pressed into thick, cream-colored slabs used in eco-friendly paper and packaging. Excess organic material is fed into giant screw conveyor digesters where it is composted into rich, dark organic fertilizer, packaged and ready to nourish the next generation of crops. Even the natural sap in bioliquids extracted during processing are bottled as golden plant-based products for cosmetics, agriculture, and industry. This is the circular economy in action, where nothing is wasted and everything has value. In the central control room, scientists monitor the zero-waste system dashboard. The screen proudly displays